Before we get into the calculus, we need to review some properties of logarithms, okay? Which is coincidentally what I'm doing right now in pre-calculus, okay? So I feel like it's all about logarithms this week. But remember that a logarithm is an exponent, right? And so we have these rules for exponents that transfer to properties of logarithms. For example, if we are multiplying inside of our logarithm, we can expand by writing two logarithms that are being what? Added together. If there is division inside of a logarithm, we can subtract the two logarithms. What about if you have something raised to a power inside of your logarithm? Okay, we're going to multiply out in front. So yes, that's a good way to describe it. It becomes a coefficient. And then this is just combining a couple of them together. But what I want you to keep in mind is that 1 over c is the same thing as like c to the negative first, right? So we could write this as negative log base b of c. Okay. You could also view this as a division and write log base b of 1 minus log base b of c. And what is log base anything of 1? 0. Okay, so you still end up with the same thing. Okay, so before we get into the calculus, we need to practice this. So I'm going to give you about 60 to 90 seconds to expand these two logarithms. Check with your neighbor, compare your two answers. Okay, here's what you should have for the first one. Does yours look like mine? Please note that you cannot break up a logarithm if there is addition or subtraction inside. It's very tempting, but we cannot do it. Okay? Will, how about you read me the second one?
The answer?
Yeah.
In
Can you tell me what you have?
I have 3 ln times x, or x plus 3, and x plus ln x plus 1.
Okay. And then what would we need to do since there's division?
Subtract.
Subtract. What would the exponent that we bring out in front be? Mm-hmm. Okay, you're close. You read it off to me, so good. Do you agree with Will?
Yes.
Okay. Now we will come back to those skills later, but they could be helpful when we are taking derivatives that involve a logarithm. Okay. Last year and in that one class, or algebra 2. When you talked about logarithms and exponentials, what is the nicest base to work with? You may not think so, but what base is used the most often? E. It's actually E. 10 is what we call the common base. All right, that's what's in our calculators. But we use base E the most often. It's the nicest one to work with, even though
I think 0 is the nicest one.
it's impossible to have log base 0.
Ooh.
Yes. So we are going to first talk about the derivative of the natural log of x. The derivative of the natural log of x. You know that 10-question quiz I gave you the other day? Now I can make it an 11-question quiz. The derivative of the natural log of x, drum roll please, 1 over x. That's not bad, right? The derivative of the natural log of x is 1 over x. So now let's write this one. What if we have a function inside of the natural log, which more times than not, you will. So if we have the derivative of the natural log of f of x, okay, let's use our chain rule knowledge. The derivative of natural log is 1 over x. So in this case, it's going to be 1 over blah, 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 whatever's inside. Okay, in this case, f. And then what do we have to do? Multiply by the derivative. Yes. Yes, it is. Okay, so we're going to do some examples here of using this rule. All right. More examples we do, the better off you are. So I think I have 1, 2, 3, 4. 4 basic examples and 1 crazy example. So let's go ahead and write these down. We have y equals the natural log of 2x. Okay. Since it's not just natural log of x, we can't just write 1 over x. Okay. We have something inside of our natural log. So the derivative of natural log is 1 over what is inside. So in this case, 1 over 2x. But then we need to apply the chain rule, so what would we need to multiply by? So it comes out to be just 1 over x. So get another one. Basically, if inside of your function is not x, then it's equation. Because it's 2x. Or like x plus 1 or x plus 5. Like, if x is Like on our quiz, we have like science real or something like that. All right, so derivative of natural log is 1 over what's inside. And in this case, we would have to multiply by 2x. So we have 2x over x squared plus 1. I'm fine with you writing it either way. And some of you may just go straight to writing it like this. That's fine. Okay? Either way, I'll take. Okay? All right, so now let's do, let's make some other rules with it. Product rule, the other P one, right? Product rule, okay? Trevor has realized that this is a product rule because we have product, okay? All right, so please help me out. What is the derivative of our first function? Times the second function plus the first function times the derivative of the second. 1 over x. Okay. So our derivative is the natural log of x plus 1. Okay. What do you think so far? You like it? I like natural log. Next one. What'd you say, Trevor? Oh, geez. That's okay. Yeah. Okay, so let's listen to Trevor here. The natural log is inside the cube. Okay? Can we expand this? We cannot. If that were x cubed, we could move the 3 out in front. But since it's the natural log of x cubed, it's not following any of those properties. Okay? So we are going to have to apply the chain rule, which is why Trevor was gluing. Okay? So outermost function is what? The cube. Okay? So we will apply the power rule. Then we can multiply by the derivative of the inside, which is 1 over x. So you can rewrite this, you can leave it as is. I don't care. All right. You can write it as a fraction, you can leave it as a product. Okay? All right. Now, time has come. Please write this example down. Okay, let's be honest with ourselves. How many of us would truly enjoy leaving it like that and taking the chain rule with the cubed root of that quotient? Okay, even if we love calculus, that does not seem very efficient, does it? Okay. If we don't have any other option, then we have to power through it. But we have another option, don't we? What is that other option? We can expand this, right? We can expand this to, first of all, be 1/3 times the natural log of this quotient. Okay? Still not worth our time to leave it like that. Okay? Our time is valuable to us. We can write this as 1/3 natural log of x minus 1 minus 1/3 natural log of x plus 1. Or would you rather just leave the 1/3 out front with parentheses. You like it like this? Okay. All right. You could do it either way. You could have 1/3 times that quantity of the subtraction, or you could have it like this. Doesn't matter. Okay? Now, how do you feel about taking this derivative? So much better, right? Like, this is, like, I'll even admit, like, that's going to be a lot of work. Okay? We can do it. But this is less room for error, don't you think? Okay? All right, so our derivative. 1/3 stays along for the ride. The derivative of the natural log of x minus 1. 1 over x minus 1. Times 1. We won't write that. Okay? Minus 1/3 stays along for the ride. Derivative of the natural log of 1 over x plus, I'm trying to talk too fast. The derivative of the natural log of x plus 1 is 1 over x plus 1. So I might write it like this. Okay, that looks better. Yes? Like the 1/3? Okay, so anytime we have a constant multiplied together, you could do the product rule, but the derivative of a constant is going to be 0, so half of the product rule is going to go away anyway. So that constant is just going to stay along with the derivative. Does that make sense? Okay. All right. On hold on. There's something that I was going to have you read. However, since we got the book, I'm not sure it is. So, all right. You may come across derivatives that look like this, okay? So before you start writing these down, why would you see an absolute value inside of a logarithm? Turn to your neighbor and talk for 20 seconds. All right, so why would we have absolute values thrown in some of those? Okay, everyone had an answer, and no one's talking. Pod 4.
Because you can't have a negative log.
Okay, we can't have negatives inside of our logarithms. The domain of a logarithm is 0 to infinity, like not including 0 to infinity. So, like the cosine of x, sometimes it's positive, sometimes it's negative. Well, we can't have anything negative, so we would have to say only one positive number. All right. So I don't want you to be worried if you see an absolute value. Okay, it just means it's not going to change the way that we find the derivative. So go ahead and write down letter B here. We're going to take the derivative of the natural log of the absolute value of cosine. Okay. So the derivative of natural log is 1 over what's inside times what's the derivative of cosine? Negative sign. Huh. What's that the same as?
Negative.
Negative tangent. Right. Any guesses before we do the math of what the derivative of the natural log of sine would be? You're guessing positive cotangent? Okay, let's see. So the derivative, 1 over what's inside times the derivative of the inside, which is sine of x, be it positive cotangent. Look at that. All right. So you remember, back in the day, when your calculator wasn't fancy, this was your change of base formula. If you had log base a of x, we could type in the natural log of x divided by the natural log of a. Do you agree with that statement? Okay, you don't necessarily need to know it. Write it down, that's fine. Okay, what we're going to do is I'm going to take this bit of information and we're going to figure out what the rule is for the derivative of log base a of x. You ready? Okay, so log base a of x, we're going to figure out the derivative by using natural log of x divided by natural log of a. Okay, so I have written it as a quotient. Now, what is true about the natural log of a? It is what? It is a number. It's a numeric value. That's not zero, probably. Okay. So when we do the quotient rule, we have the, well, really, let's think about this. 1 over the natural log of a is a number, right? Multiplied to the natural log of x. And what's the derivative of the natural log of x? 1 over x. Okay? So, what I need you to know, you don't have to come up with that for me again, but you need to remember that the derivative of log base a of x is 1 over x, just like natural log. However, if the base is not e, we have to multiply by natural log of a. So we have one little step extra. It's still the 1 over what's inside, but we also have to multiply the denominator by the natural log of the base. What's the natural log of e? 1, which is why this step is not necessary for natural log. Okay, and just like before, if we have something else inside that's not x, okay, then we would have to apply the chain rule. This is just a different way of writing it. Okay, so if we have something else inside, we know that we need to apply the chain rule. We're going to go through a few examples for this, and then I'm going to show you one technique that can save us with some tricky problems. Okay. Okay. We will start small. Log base 3 of x. Okay, so since it's a logarithm, we're always going to do the 1 over x, but since it is not natural log, we are going to have to multiply by the natural log of the base. Does that make sense? Okay. Okay, let's do this one. Log base 3 of 3x. Okay. Some of you are realizing we are going to get the same thing, but let's just go through it, okay? So since we have a logarithm, we're going to have 1 over what's inside. Since it's not the natural log, we will have to multiply by the natural log of the base in that denominator. Okay, so there's the log rule. Then we have to apply the chain rule. We'll multiply by 3 because that's the derivative of the inside. Okay, so yes, the 3's cancel and we end up with the same thing, and that's fine. What's the base here? The base is 10, all right? So when we take our derivative, we have a logarithm. 1 over the inside of our logarithm, but since it's not natural log, we're going to have to multiply by the natural log of the base. Our base isn't written, but it is implied that it's base 10. Okay? Times, what's the derivative of the inside? Negative sine of x. All right, in the interest of time, we are not going to do this example, but I want to talk about it. Before you take this derivative, what would it be a good idea to do? Expand and then take the derivative. All right? Now, keeping that in mind, go ahead and write down this example. This is the last thing that we will do. Let's talk about taking this derivative. Do you feel any bit of anxiety just thinking about taking this derivative? Okay, there's a lot going on here, right? We have a quotient rule, and within that quotient rule, we have some chain rules, right? Now, it's not impossible. However, the power of logarithms could help us here, okay? Is this a logarithmic problem? No, but we could use a technique called logarithmic differentiation, where we can take the logarithm to both sides. Doing something to both sides of an equation does not affect the value. It is still equal. But by taking the natural log to both sides, what does that give us the option of doing on the right side? We can expand and the derivative is not as messy. Okay? So we can, on the right side, write this as 2 natural log of x minus 2 minus 1/2 natural log of x squared plus 1. Now, notice how we have created an implicit problem now. Good thing we know implicit differentiation. Okay. So when we go here to the natural log of y, the derivative of the natural log of y would be 1 over y dy dx. The derivative of 2 times the natural log of x minus 2 would be 2 times the derivative of the natural log of x minus 2. Minus 1/2 times the derivative of the natural log would be 1 over what's inside times the derivative of what's inside. So I'm just going to make this look a little prettier. Okay, we have 2 over x minus 2 minus, these two can cancel, and we have x over x squared plus 1. Now, did this problem start off as an implicit problem? It did not. which means I do not want your answer to be an implicit derivative. So to solve for dy dx, we are going to have to divide 1 over y over, which we all know dividing by 1 over y is the same thing as multiplying by y. However, what am I going to expect you to do with that y? You don't have to distribute it, but since our problem started off explicit, your derivative needs to be explicit. So instead of writing y, I need this to be in terms of x, so it is explicit. So we're just going to change y to x minus 2 squared over the square root of x squared plus 1, because that's what y is.
Will this be on a test, like a problem like this?
Yes. So here's the thing, Trevor. Do your homework tonight, and our warm-up problem is going to be another problem like this, so we can talk about it again. Okay? So, thank you for your patience. Tomorrow we will obviously go over our homework. Know that you have a quiz the middle of next week. So this 4-day weekend is going to be important for you to catch up on any missing daily assignment. Yes. Okay.